So welcome back. Up next we have Andrey Chubin, lead data scientist at Quantum One. He will share his knowledge on hybrid search and semantic AI for domain-specific application. Andrey, the floor is yours.
Thank you. Thank you very much. Just let me share my presentation. So I hope everyone sees the presentation right now. So today we will be speaking about basically how to build a proper search that is tailored for your application, whether it is a platform, a website, some catalog, or a rec system. The main point will be here that we will be basically today discussing how to do this for the specific domain that you're operating with. Sorry. And before we are jumping into the content of the presentation itself, I'd like to give some introduction about what we will be speaking today. So first of all, for those who are not that familiar with the topic, we will be speaking about why actually the search is worth investing in it. Like why not to keep it traditional? Why not to keep it simple? Why should you go with some complex things there and introduce really advanced tool to enhance the experience of the user? Then we will start with the basics and we will step up each time. So first we will speak about what are the traditional methods, where actually could you start with, what has actually proven itself to work for many, many years. We will also discuss what are the drawbacks of those approaches, then we will discuss how can we overcome them, and then we will go deeper into the main specifics. And then we will try to connect the search, basically that was tailored for your specific use case, with the business goals that you have. And then we will combine everything together and basically discuss how the hybrid system that will accommodate for the different use cases can be built. And at the end, we will discuss also how can you reduce some of the parts of the solution that we will be discussing today in different topics. So how can you profit actually from what I will be presenting today, how you could profit it in the areas except for the search. So why search? Why it is so important in so many topics? So basically, as many of us know, or maybe all of us already know, that the people, they struggle in both cases. Like if you have no choice, then no decision will be made. And if you have too much choice, it's basically the same. So if you have too many options, it's really hard to decide which one to pick. And the search basically helps to narrow down the list of the set of the options for the customer, which helps the customer to make the decision on whether to buy something, to convert, to watch a movie, etc., etc., etc. So in many places like e-commerce, food delivery apps, I don't know, the entertainment platforms like Netflix, for example, you have search as like the go-to thing, like it's the entry point in many cases. From my experience, so I worked previously at e-commerce and food delivery. And the statistics says that around a third of all sessions, they start directly with a search query, which means that the user, they don't actually use any other widgets. They don't look into the discovery you're providing to them. They're going straight to the search. So either they already know what they're looking for, or they at least have something in mind what they actually, the areas that what they want to explore. But if they don't meet their expectations, what we observed is that the users, when they get frustrated with a search result because of the poor quality of it, they actually tend to churn, they tend to drop the session and go to the other platform that provides a better experience. For example, in our case, when the search was only in its early stages and it wasn't able to provide actually the full functionality, we observed that the 70% of the users who used the search, they weren't able to find what they were looking for. And they didn't use the discovery page. They didn't use the other widgets that actually should help them to find their goal. They actually dropped there immediately and they did not continue with their session. So by improving the search, basically we're improving our funnel at the very start. So we're funneling more users into the next steps, which eventually leads us to increased conversion, views, interactions, etc., etc., etc. So what are like your maybe the thing where you could start? So the basics is, and actually when the people think about the search, they most probably thinking about the exact match. It's basically when you're entering some word and this substring is compared with the items in your catalog. For example, if you type MCD in the food delivery app, most probably like we expect the McDonald's would be at the top. Actually, just as a disclaimer, I will be using today the examples from the food delivery app. I think most of the people here should be familiar with the topic, used at least once or a few times different applications, and basically should really know what's there and have the experience using that. So it should be close to us. So here, the exact match MCD will give you the McDonald's. You also, the next step from that, like we know exact match is a good thing to start, but the people tend to have a typo or misspellings in what they're querying, and the exact match will fail in this case. So you have then the fuzzy matching. It's basically a few, or actually there are like a list of approaches how you actually can compare misspelled words to the catalog you have and to provide the most relevant outcomes. The problem here is it's really hard to find the exact like the approach you really need to use, because there are multiple of them and they each like tend to serve their own task. So many of you probably heard about the Levenstein distance, but for example, if your items, I don't know, you're maybe running some store that sells tools or something, I don't know, some electrical equipment, and those tend to have a lot of abbreviations in their name. And the change in the letter in the abbreviation might actually completely change the meaning of this item. And the Levenstein distance actually wouldn't be able to capture that. So there are other approaches that actually will help in this case, but you might have like different cases in the same catalog, and selecting the appropriate approach would be really hard. The next one, this is, I think, is one of the most popular right now, used almost everywhere, is the BM25. This one is using the tokens. It compares basically. So here you actually, it is more used to extract the documents. When you have the content of the document, you type maybe something, and then it uses the keyword match to get you the best relevant document. But the problem here is the same. It relies on the keywords. It relies on exact words instead of the meaning. So when the meaning kicks in, when the customer is not looking for something exactly, but rather is looking for like conceptually, then the traditional methods would fail in this case. Like, for example, if you're looking for the Chinese restaurants in your area, and you try to type this in your search bar, the Chinese, The search that uses the traditional methods only will output you only the restaurants that have Chinese in the restaurant's name, or maybe in the menu if the additional information is used, or if it uses some text. But if the restaurant have none of this, but it's still a Chinese restaurant, it will not be in the selection at all, which means that actually a lot of relevant items will not be in the search result, which is, of course, not what we're looking for. Another one is that, for example, if you're typing burger, you're not like, you would have the places, you would have the restaurants that serve, that have burger in the menu, that have the burger in the name, but they would be ranked on the closeness to the query alone, without taking into account like whether some place is more popular or more well-known than the other. So in the later phases of this presentation, we will discuss actually how to overcome both of those issues. So the first one, how can you work around this bottleneck of the exact match versus the conceptual search or the semantic search? So here, right now, this topic is actually pretty well known. You can use some approaches. Here we will be concentrating at the most modern one is to use some pre-trained models like LLMs, or maybe some older models but of smaller size, to vectorize the items in your catalog. So basically you get the embeddings, and you get the embedding of the user's query. And then you basically compare using some similarity score both of those embeddings, and you output the items that have the highest similarity score to the user's query. On the surface, it sounds great and it works in most of the cases, but if your use case is really domain specific, you should be really cautious with this approach. Why? Because most of the model, they are not domain aware. So they are trained on the general text, because the companies, the researchers that try to train their models, they try to use as much text as is possible. So they tend to use like the general knowledge to train the models. And this leads to actually to the complexity where the same tokens, the same words can actually mean completely different thing in the different domains. For example, a cat as an animal might not be, for example, this, like the word cat might not mean the same if you're selling the construction equipment. It might be a caterpillar. But since cat as an animal appears way more often in the training data, the model would actually tend to always classify your cat as an animal instead of a manufacturer. Of course, the modern LLMs, they take the context into account when they're creating an embedding, but it's still not actually serving the full purpose. Like, it's still, there can be complexities, there can be misrankings, etc., etc. And all of these basically leads to the relevant results. So now you're providing this conceptual search functionality in your application or in your platform, but the results are still relevant. So let's look at the example. So here, this is what we actually started with. To prove the concept, we took the general model, we took the OpenAI's text embedding, and we tried to vectorize the restaurants to use this later for our semantic search. So here, as you see, for each item, we use the restaurant name, we use some text if they were available, and we used some items from the menu. Why not to use the whole menu? Like, we used only some fraction of it. It's the same problem if you with the LLMs, with the tiny language models, is that actually if you have too much, if you have your context is too long, it's actually can dilute the results. So you want it's actually to keep really slick, you want to keep it small, and you want to keep it straightforward. So only to keep the information that is the most relevant to the item that you are vectorizing. And what we can see here is actually like both of them restaurants. So if you will look here at the score between the items themselves, 0.64, they don't seem to be very narrow to each other, not very far away, something somewhere in between. Even those, like, it's debatable in the terms of the food delivery, because both of them are kind of very well-known food chain restaurants. They serve the fast food. Actually, some of the items in the menu, they overlap in general. And we're speaking here about the OpenAI's model. Like it has actually the knowledge about McDonald's and KFC, even without us providing the menu items. But what was the most unexpected is that the distance between the query, which is the burger here, was extremely low. You would not expect actually the McDonald's to be that far away from the burger. And especially like for KFC, it might seem to be legit, but the problem is like the burger is an incomplete query. It might be a chicken burger. And we want actually, like, if the customer typed burger, we want to have like the places that serve burger, even if this burger made of chicken. So we see here that actually the scores, they are completely relevant, which means that McDonald's and KFC, they would be ranked relatively low in our outcome. And it's not what we actually expect from our search to do. So what can we do about that? So how can we fine-tune the model? So this is basically the answer. We can use the domain-specific fine-tuning. So basically to use the knowledge about your items to train the model to understand the domain, which will lead actually to much better results, because now all of those complexities I mentioned before, they will be handled internally by the model. So how do we begin with that? So of course, every machine learning exercise starts with the data. You need data to fine tune. This is obvious. If you already have search, then you're lucky, because you already have some data set. You have the history of the search queries. You have the history of the user's interaction after the search. So basically, you already can connect these dots, and you can build your data set. If you don't have that, it would be best, of course, to start immediately. If you see that there is a need for such functionality on your platform, you can already start using the methods that I mentioned before. Yes, they wouldn't be ideal, but it's better than having nothing. And you will be able already to start collecting the data. But in the meantime, you can use, for example, ChatGPT or Gemini to get the synthetic data set. And it seems a bit contradictory to what I said before, but there in the previous on the previous slide, we actually were more talking about the mathematical terms, the similarities, embeddings, etc. Here it's more like it's the task that can be assigned to a human, but actually can be sometimes solved by the LLM itself. It won't be 100% correct. So what we want to achieve here, we give the item to the LLM and we say, okay, come up with a list of possible user queries that could lead to this item. And we will create a huge data set of those synthetic queries that will lead to our items. And then you can engage with the domain experts to turn this synthetic data set into a curated data set. So the domain experts can actually, yes, this will be a manual work, but it's worth it. Actually, it pays off. It's actually what we did in our company. We had the data of the previous search queries, but it wasn't enough. So what we used, we enriched it with the synthetic data, and then we engaged with domain experts to make it cleaner, to make it more obvious to the model, to capture all of the patterns. So after you collected the data, you need to select actually what model would you fine tune. Here, it's actually most of the time, it doesn't pay off to fine tune the large language models. Like OpenAI with the ChatGPT, they provide the functionality of fine tuning the models. Well, at least it was for a few months ago. But it's most of the time, it's just not worth it. You most probably wouldn't have that many like data samples to change anything in the latent space of such a huge model. And from cost perspective, it's just not worth it. It will not pay off because it will cost you too much. The better approach is to use a tiny model. Of course, you need to be here, like you need to be aware of the language. Either you use the separate models for the separate languages, or you take the tiny multi-language model. In our case, for example, we went for the tiny bird, but it's actually, it could be any other model that suits your task the best. So with a tiny model, you don't need too many resources to retrain it, to fine tune it, and you can actually iterate much faster, and it will be enough. It will be enough for this use case. It will be enough actually to vectorize all of the items in your catalog. On top of that, you can enrich your data with some additional information like menu items, as I showed on the previous slide, product specs, business taxonomy. For example, if you have the hierarchy, you can include this one as well. And as I said before, just keep it, don't let it overblow. It should be relatively small. Each item shouldn't take like few pages because it will be just really hard for the model to digest all of this additional information. As for the training goal, we're going here for the contrastive loss, which means that we want to actually, right now we have the model, it has some latent space where, let's imagine like some two-dimensional plane where each dot is our items. What we want to do is when we want to put the similar items in a cluster, and we want to increase the distance between the dissimilar items, which means we will train the model not to try to predict from the query itself what will be the item. Instead, we will be training the model to understand whether the query and the item are close. And on top of that, we can add whether the item and the other item are close or distant from themselves, and it will pay off later. So let's look at the outcomes of the model that we trained here for our domain for the food delivery app. You now see that the numbers are completely different. Like maybe the one we've seen previously makes sense for the general use case, but this one makes more sense in terms of the food apps. So we see already that McDonald's and KFC, they are much closer to each other. They're actually like really close, and it makes a lot of sense because many people, when they think about those restaurant chains, like very big, very popular restaurant chains, it's actually the McDonald's, the KFC, and some others that actually popping up the first. We also see how actually the query itself became close to the items in this example. Like the McDonald's is extremely close to burger, and it makes a lot of sense right now because when we think about the burger, even if you're not into this type of food, if you're like some high-end burgers, there is no way you don't know about McDonald's. Like it's the thing that comes up the first, and it's actually what we want to achieve in our search exercise. But actually, sometimes, like this one, this was the case when the semantic search was provided very good results, but it's not always the case. So sometimes the best semantic match is not the best result for you or for the customer. Because you're not taking into account any other factors. For example, let's imagine there was a place that had the similarity to burger query of 0.99. And this is a place that no one knows. And the food is terrible there. Like, it has few reviews and they're very bad, but the semantic similarity is very high. And if we'll use the semantic similarity alone, it will rank really, really high. And we don't want to do that because the customer seeing that as on the first place in the search results might think that this is actually the place to go for. They will order, they won't like it, and they won't get back to your platform. So here, what I want to introduce is the re-ranking. Is that yes, the semantic search will give us the candidates that we will show in our search, but we don't know their order yet. To actually re-rank them, we need to bring the business metrics in. We need to bring our goals into that. And this can be done in different ways. For example, you can combine the semantic match with a CTR. Like, you can boost the items that are more prone to be clicked on top of your search query. For example, in case with a burger, we know that McDonald's is the most popular, by far the most popular restaurant in this category. And we will add this popularity to the final score, which will rank this restaurant much higher, even though the semantic similarity was actually lower than by some other restaurants. Also, maybe if you're using the food delivery apps a lot, you might notice sometimes that if you go to a search bar in the peak hours, and you input the restaurant, you're searching for the restaurants, you might notice that sometimes, it depends, of course, on the app you're using, but sometimes the outcomes of the search are not the same you probably seen in the morning. This is when the companies are actually trying they lower your experience because you don't see probably you don't see the places you're looking for. But they're trying to solve their marketplace health during the peak hours. For example, they don't have too many delivery personnel. So what they will do, they will rank higher the restaurants that are closer to you. This way, you will be more prone to order actually from this selection from the restaurants that are closer to you. It will increase the recovery of the delivery personnel. So if the delivery distance is small, you can reuse the same personnel earlier for the next deliveries as it would be if, for example, the restaurant you want to order from is on the other side of the city. Another way to approach that, you can actually train a separate model, which is this is the family of models that called learn to rank. Here, you actually can go even deeper. So if we discussed previously, this was like a general one, like popularity, but it's general popularity, marketplace health, but it does not connect to you directly. If you're using learn to rank, you actually can tailor your search outcomes for every user. Like, for example, there is a user that orders high-end cuisine on the Friday evenings, and on the rest of the week, there is the same the same query, the same orders as usual. Some mid-ranged restaurant with good quality food, but nothing super fancy. But since you already know that this user on Friday evening has a pattern to go for the high-end restaurants, when at this time the user will query for a burger, you already know that actually right now the person is not looking for what this person was looking regularly. Now you need to show the high-end places instead of the regular ones, even though it's the same query of a burger. You don't show McDonald's anymore because it's not relevant for the user. And you can train it for the different use cases. Like, you can tailor it a lot, and you're step already here into the recommender system area. And this is before on So on the next slide, I will explain how we will combine together, and then we will dive a bit more into how can we reuse your LTR model, the learn to rank, and how can we reuse your language model that was fine-tuned to your domain in the different areas. But let's first finalize here. The hybrid search, basically the high point of the whole presentation, of the whole workshop here. The thing is, if you build the best semantic model possible for your domain, you learn how to re-rank the candidates out from the plethora of the items available at your platform. There is a problem because sometimes the user is still searching for the exact match. It's still happening. And if the user already know what is looking for, even the best semantic model is not guaranteed to place those exact matches at the top, because it looks at the meaning instead of looking at the string or the names themselves. So to build actually the complete product, you need to combine the approaches that we discussed at the beginning with the more advanced things that we discussed just recently. So how can you do that? How can you accommodate for the multiple use cases? For the use case when the customer is already know what he or she is looking for, like the exact match, or when the customer is not fully aware of what it should be, but conceptually they already know what they're looking for, which is the semantic search. So the first idea might be is we can try to combine the score. We can just weight the lexical score, which is how the strings themselves are close to each other, with the semantic score is how the meaning of the query and the item are close to each other. But the problem is that weighting both of them it's really hard. It's really hard. Like finding this sweet spot it takes a lot of research, and it might be non-existing because it might be changing all the time, and finding it dynamically wouldn't be possible. So here, if you already know how to weight this, you can use like the very straightforward approach, or there is a better way actually to do this sometimes. It depends on the use case. There are actually multiple things how can you approach this problem, but you can actually go it from the product perspective. You can dedicate some of the top places in your search output to the exact match results. Basically, so when the customer is inputting their query, you're making two searches in parallel. First one is the semantic one that we discussed. Another one is a lexical one. And if you get the candidates that have a really high lexical score, you select the best of them and you place them in the dedicated spots that should be on top. This way, you're actually assuring that the best possible scores so the best possible outputs, they're always there. That even if the customer is looking for the exact match and you weren't sure that it is the case, you will be still showing those exact match candidates, and you will be able to fulfill the user's intent in this case. So what can we do beyond search? So we spend some time, but maybe search is not the main thing on your in your product, in your platform, despite that we discussed previously. But actually, even if it's the case, you can still use it, you can still benefit from it. So the first one where we can go is the recommended systems. We already touched this a bit with the learn to rank models, but actually, like, we can go even deeper than that. Now you have your items vectorized, so you can use any math now you want. You can go with some factorization machines. You can go with deep learning, collaborative filtering. You can do the item-to-item things really easily. For example, imagine what the Netflix does. If you watch the movie, you go on the main page and you see the selection of the movies that states like in the title, like because you watched this, you see this. And this is actually a very powerful widget that can be fueled by this model, because now you have your item that the customer, like it's called the anchor item. The user, I don't know, bought something and you want to show him some similar things tailored maybe for his or her tasters. This is possible, and this is now much easier to do. The other one, you can actually use like user to item things. Like, you see that the users, for example, some users tend to buy from some place, but you don't try to recommend this place to the other similar users. Instead, you can actually scale it to the different, like maybe there is some user who likes some topic or some concept of the cuisine in some area, and in the other areas you don't have the same restaurants, but you can translate this information about this user. You can find the similar users in the other area and try to search for the restaurants that are suit the best the selection of the training set. So this way you can actually boost your cross-sell, your upsell, your recommender systems, actually with little investments, because you already invested in the core engine. The next one is actually the query intent detection. This can be used, for example, in a chatbots. This can be used also in the search. So sometimes your items, like they can be hierarchical. Like in the food, you have the cuisine, you have a brand, and then you have the dishes. And actually, the customer might look for any of those. The customer might look for Italian cuisine, or it might look for a pasta, which is a completely different thing, because in the latter one, you need to show only the places that serve pasta. And actually, if your data set is big enough, like it just covers those cases, the model will be able, and we observed that in our case, that the model is able to distinguish between those intents by itself out of the box. So it does not require any additional instruments to do that. It doesn't work 100% of the time, but of course there are always some corner cases where even the people are struggling. Then it is the clustering. Since now we placed each item in the clusters in the latent space of the model, we're able to build some new categories, for example. In our case, when we were researching the outcomes of the fine-tuning, we found out that the model could actually distinguish between the category inside the categories that we had. For example, the Arabic cuisine, the model was able to extract only the Syrian restaurants, for example, or only the Egyptian ones. And sometimes the people that order from the Arabic restaurants, they are actually looking only for those specificities that weren't captured before. And we didn't know that because we ourselves are not that familiar with the differences in the local cuisines and the regional cuisines. How can this be used? You can, for example, automate the creation of the special selections that are tailored for the user. For example, the same goes for the food domain. Like you say, okay, we know you like, I don't know, not the Italian, but Neapolitan, or I don't know, Milano cuisine. Here is the list of the best Milano cuisines in your area, or the ones that have the biggest discount. The same way you can actually do with ads or a lot of other things. Like it's actually this knowledge is transferable between the different use tasks. And the last one, very popular right now, the RACs. Like you know that in RAC you have this retrieval step, and it's really, really important that what you retrieve from your vector database is the most relevant to the user query. We faced the problem in the oil and gas domain when, for example, the customer was looking for the like the question was, for example, how should I place an electrical cable in this exact situation? And the model, that like just the general ChatGPT, wasn't able actually to distinguish between the specifications for the onshore and offshore electrical guidelines. That's because those guidelines, they were 97% the same, but it's actually those 3% that mean the most. And this is obvious for the domain expert. It's not obvious for the model that is trained on the general knowledge. So here, you're still using for generating the output, you're still using the same LLMs that you used before, but for the retrieval phase, when you try to augment the query with additional information, you use the fine-tuned model that is best suited for the case you're doing. So here, the model would be able actually to understand that it needs to search for the onshore or offshore, depending on the use case. Or if we weren't so sure, we could actually ask the following question to the customer, stating that, see, there is a difference actually. We found a few completely different guidelines, and we want to know more. Basically enriching and enhancing the experience that the customer gets from our LLM systems. So basically, so on the last slide, I collected the key takeaways, things like the highlight of the presentation, and I suggest to go to the questions if there are any. Sorry, I need to click. So let me. Yep. This is a great, Maria, this is a great question, actually. Yeah. This is very important. Like many companies, they actually hunt for this feedback, because yes, you can reuse this later. What is the benefit of using the small models is that actually you can iterate really fast. And sometimes just having the information from the query history, search history itself might not be enough. And you actually can relabel. Okay, I'm sorry. I'm sorry. Let me share the screen. I hope you see the one. I'll try to open the chat. Yeah, so the question, the Maria's question was, can user feedback be used for generating so on the query, so for enriching the results? Yes. So you can relabel, you can add new data, you can actually use this to re-rank, especially for the personal one. And this is why, for example, in many apps, especially in the OpenAI, when you see the outcomes, you have, for example, you given an option to decide between two of them outputs, or you need to rank. It helps the system to adapt. And it's, as I said, not that hard to do, because you have the binary output here. You can place it directly in your training set, and just next time you will be retraining or fine-tuning your model, you will be taking this into account. What is the impact of tabular data in your documents on the embedding? How to adapt? Not clear, actually, what are your asking here, because I faced actually like different things. Sometimes, like if you were speaking about the LLMs and there are tables inside, especially if those are some PDF documents and you need to vectorize that, this is really hard. So something like it's hard to process them. Yeah. This is a topic that can be assessed in different ways. Just having them directly in your LLM most of the time don't work because the model isn't unable to understand that there is a tables going on. And it's also the same thing as sometimes with abbreviations. So here's the two things is like one thing actually, but for the both cases you can do is replacing this. You're extracting we don't see your I think it's just you don't see the questions. Oh, I'm sorry. I thought actually Is the organizer there? Can you help us with this one? Because I'm was sharing them, but it seems that the
Yeah,
Zoom covers them.
we are here. Maybe you can just because I don't know why it's not working, but you can maybe read the question
Yeah,
first and
sure. So the question of Matthias was how to process the PDF documents. It's a bit in the tabular in the documents that contain the tabular data. It's a bit off from today's topic, but it's better to replace. So extract the tables separately and replace them with the format that is most that can be read by the model. It's either some JSON format or another one that can be, it's just the important thing is just to be consistent here and to use the same. For the abbreviations, the same. You need to provide more information to the model. You need, instead of using the abbreviation, use the full name. So this is actually, but still debatable because for different use cases can be. Use llama, that's the problem. So the Milan asked whether can we use llama to parse the tables? We can, but what we faced is that even the most advanced LLMs, they don't provide the results that are reliable. This is especially true if you have the PDFs of the different formats. So sometimes when you try to convert your PDF to the text format or something structured, you don't get the tables in the same format all the time. And it's something that is hard to automate. Usually, if you're working with one type of document, you need to write your own extractor, your own parser that will be specially dedicated only to those tables to extract the information and then to convert it manually. So automation here works 50% of the time. Wouldn't say that it's that reliable, but it's if you don't have any other means to extract this information, this is of course the one I would go for. So I don't see actually any new questions. The presentation, Michaela, yes, I think I can share the presentation with the organizers and they will share it with everyone. I think there was such an option. Okay, there is one more question by Miodrag. So what about the retrieval cost in different strategies you mentioned? Actually, so if you use, there is not much difference. I would say, of course, the latter one, the hybrid one, will be the most expensive because you will be doing different extraction, different searches at the same time, like BM25 or even the vector search is actually embedded already in many solutions like OpenSearch, like Elasticsearch. If you're using the same, as I said, like if you're fine-tuning the model, your only extra cost comes from the fine-tuning. And if you use a tiny model, those costs are not that high. Like you basically need to have, you can rent an AWS machine and it wouldn't be that much. Since you will be processing all of your items before you do the before you do your search, you actually have already everything stored in your vector database, and the only things you need to process will be the query itself. But since you're using a small model, you actually can have, like, you can speed it up a lot. You can use different different inference techniques, how to make it cheaper. But in general, it wouldn't be, because inference you can do without the GPU. So you can use the cheap CPU to do the inference. That's it. So we actually, the costs didn't increase for us any, like, it wasn't significant for us to actually even mention that topic. But if you'll try to actually use your the large language model, as I pointed before, the OpenAI or the Gemini, this will explode the costs a lot. Like, even getting all of your items vectorized using the OpenAI embeddings. Of course, it depends on how many items you have. But if you have, for example, like 100,000 or more, and you would have, like, you have the constant stream of new items added to your platform, this can explode the costs. So it's also like a bonus point to the fine tuning.
Sorry to
Okay.
interrupt you.
Yeah.
Because we have still time, do you have to add something more about this topic? And I would like to tell the people that they can freely ask question that you need to answer, and the presentation, you can send the link in the chat so people can access it.
Okay, sure. I don't have a link because it's locally. I think we can discuss it with the organizers later, and then just
Yeah.
share with the emails or something. Is it the
Yeah.
option?
Yeah, it's good option.
Okay, great. Thank you. Actually, yeah, on the topic, I think I've already, like, presented all of the knowledge that I plan to present today. I think there's one more question left. Do we have time to answer that one, or we need to go to a next session already?
Sorry, can you upload your local version of PDF in chat? Do you have that option?
Yeah, let me try that one. Let me try. If it's allowed by the admin, it should be feasible. Yeah, it's already uploading.
Yeah,
So
perfect. Thank you.
let me answer the last question. I think here, like, you said that the model was able to recognize the subcategories of the cuisines inside of the bigger categories. Have you noticed similar behavior in retail data, where those new subcategories clear to describe because of the greater number of items and categories per basket? Well, we noticed the same one is in the groceries, which is really close to the because the retail data can be a bit like a broader topic. You might be like, I don't know, selling cell phones or some electric equipment. Might be a lot. What we've seen is sometimes, yes, you have actually you don't have this variety inside the categories. Like, if you have cucumbers, most probably the model wouldn't be able to recognize the differences because between the cucumbers, like, or do they have the pointy sides, or those are smooth cucumbers. But in some of the, like, in some of the categories, yes, it still applies. But it's much harder in the groceries. Like, it's heavily dependent on your area. Like, if we're talking about the difference between the upmarket things, for example, you have milk. You have something like really organic, expensive milk, and you have the milk that is just like for like a more affordable one, yes, the model is still able to recognize this differences. So for example, if you know that the customer is more in the high-end stuff, you can still use the model to actually take from subcategory this this sentiment. So that this is one is the upmarket, but you wouldn't be able, of course, to have these differences between like Lebanese, Syrian, or Egyptian cuisine. That this will be much harder to achieve. What do you think about the agentic approach in RAG? Should we already implement all query flows like chain of thoughts, etc., in agentic manner? Is it already best practice? Well, it's heavily dependent on the case, because in most, like I mentioned and sample from the oil and gas, and sometimes, and it's also valid for all high risk applications. So you shouldn't be like an agent. It's still an LLM that making a decision. So when you're adding a lot of agents in your chain, you're actually decreasing the you can rely less. So it depends if you're in your case, for example, you're not that concerned about the errors. I would go for it. Also, there is a cost. So in me personally, I try to keep it simpler. For example, like I mentioned before, sometimes for retrieval, you don't need that. For cases, chain of thoughts is also in very interesting stuff. Sometimes works, sometimes it doesn't. So really, like the question is too broad, but it's up to the case. Couldn't say there more. What methods do you recommend to generate additional product info, e.g., creating additional tags or categories, grouping products, and naming those groups, etc.? Good question. That's a good question. So here, if you fine-tune your model and you actually already know that you're looking for some tags, yes, the fine-tuning and the approach that I mentioned does not gives you the opportunity to generate something like out of the box. You need to have here some additional tools. First of all, if you already have a list, you have a list of tags that you want to assign to some items, you can use this search, you select a threshold, and you use those tags as a query. This is what we used, for example, as I mentioned in my presentation about the special selections. We had a widget that was dynamically, like the categories in this widget, they change like every week, and there are new categories each time. And previously, those categories, like to each of the category, the restaurants, they were assigned manually. Those are, for example, instead of having like Indian cuisine, it's now only the Kerala. But we don't have the information whether this restaurant serves only the Kerala, like that come from Kerala, or whether this is North or South Indian, or it's Iranian, because usually it's just it's inside the Arabic cuisine, and we didn't have this tags. And we were able to, by using those similarity between the query and the embedding of the item, we were able to assign each restaurant to this category. So if you know already, if you have in your mind what categories you're looking for, you can assign that. So including method that can be applied to new products. Here it's not a problem. Like if you have the fine-tuned model, it still works on the new problem. This is like the best thing here. If, for example, a new item is added to the catalog, you don't need to retrain the model. Like you would be retraining just to enhance the results, but you can still use, because it's like you're using the same approach as used to train the LLMs. You can break down this item into tokens, you input it to the model, and if those are like kind of homogeneous, like as I said before, like only restaurants, you would be like guaranteed to get like this one, like very, very good categorized, so you can still input this new item to the all pipelines I mentioned before. Hope this answers the question. Okay. The question from Matthias: which embedding models are good best practice for image embedding semantic search? Well, I'm not that into the image thing, so I wouldn't be able to answer that. As I said, it all depends on the your use case. So sometimes especially on the language, because most of the models, they're very good for English, but if you're operating in a different language, you need to actually look for the models that were fine-tuned for this specific language. And sometimes for some languages, the list of the models that will be accessible to you is very narrow. For general application here, for example, as I said, we use the BERT, very well known, pretty old in comparison to OpenAI, but still very solid. Wouldn't go for example, for the case I've mentioned, even if we're not going to LLMs, I wouldn't go for very advanced models that are on the Hugging Face just because of their size. So you're just looking here for the models that are small, and for fine tuning, the small model you just means you have more chances to change all of the connections in the transformer layer that could accommodate for your use case. So this is also doesn't have the direct answer to this question. Okay, I hope I covered all of the questions. So if no more left.
Do you have more question?
Yes, I don't see the more. Yes, Stefan, the presentation is uploaded a bit before. I can re-upload it right now if you don't see the history. Yeah, thanks everyone for attending this session. I hope it was helpful. Sorry. No, it's.
Can you maybe send to everyone just to?
I have only two options. I have only two options here actually to send. I can see. I can send to organizer and
maybe
organizer.
I will just do now.
Yeah. Can you just re-upload it?
Yeah. I will.
Thank you. No, it's okay. It's I just can't send the messages to the general public, unfortunately. Even the Google link I can, but it will be sent right now.
I sent it, so you can correct me if you can see it in the chat. No problem. You're welcome. Do we have more question for Andrey? So I would like to thank you, Andrey, for an interesting presentation. We will have a short break now, and we will continue with the program at 1:30.
Thank you. Thank you, everyone.